Welcome to Geometry, and our lesson today is going to cover some things that are related to the transformations that we've been doing. So let's start with the Desmos activity. Hopefully you've rated yourself well on your laziness. Now, recall that a reflection is just a flip across a line, and that line is called the line of reflection that's shown here. In the next screen, what you can see are a series of two reflections. Okay. Anytime we have a series of reflections, we can create something called a translation or a rotation by those. Those are the compositions when you use more than one of those. A composition of reflections when we do it across parallel lines will result in a translation as shown here. Blue went to red, red went to green. That could have been accomplished simply by taking and sliding blue all the way to green. Let's go ahead and do one on the screen. You can see we have triangle ABC, and it first asks us to reflect it across line L. Okay. And we're going to label that image A prime, B prime, C prime. So first of all, let's make sure we understand what we're reflecting across. It's this line right here that we'll reflect it across. Now the cool thing is, when we look at our first point A is on the line of reflection, so A prime will be at the exact same spot. Anything on a line of reflection does not move. Let's look where B is. B is 1, 2 above that line, so we're going to go 1, 2 below, and this is where B prime will be, at this spot right here. Let's label this point B prime. And then C is just simply 1 above. It's going to end up being 1 below, and that is where C prime is. I'll go ahead and connect all of these so you can see where our triangle is. You should do the same on your screen using the segment tool. So this pre-image ABC is now at A prime, B prime, C prime, and now we're going to consider the other line of reflection and repeat the same process but across this line. So A is 1, 2, 3 above, or A prime. So A double prime will be 1, 2, 3 below. Down here will be where A double prime will be. At this spot right here. Okay. Let's go ahead and do B. B is 1 above. B double prime will be 1 below. B double prime. And then C, 1, 2 above. C double prime will be 2 below the line M. Once again, we'll connect the dots here, and you can see that we have created a new triangle, the exact same size and shape of the one above, but it has been slid all the way down to here. So it does ask us what single transformation would have mapped A B, C to A prime, B prime. Well, it would have been just a translation. Notice how far down it went. It went 1, 2, 3, 4, 5, 6. So this reflection could have been done by just translating the, oops, if I can spell, the triangle down 6. C to C double prime, B to B double prime, we'll drop it down 6. Now there's a unique thing. If you'll notice, the lines are 1, 2, 3 apart. So if you do a reflection off the first one and the second one, it's going to be 6 apart. if they were 4 apart, guess what? The original and double primes would be 8 apart. If they started out at 5, it always doubles. It would be 10. So just a unique thing that you'll be able to use when answering these types of questions. The next screen has another one. You can do that on your own. I'm going to move on to the next topic, and that is when we do the reflections across lines that aren't parallel, lines that are intersecting. And you can see that the blue triangle went to the red triangle and to the green triangle. By doing those two reflections, we could have accomplished the same thing by rotating it. And it actually shows in the diagram what will actually happen. If the lines are, say, 40 degrees apart, the beginning triangle and the ending triangle will always be double that, or 80 degrees apart. Let's go ahead and try one on the next screen. First of all, we're going to reflect this triangle across the line L. That's the vertical line, the y-axis here. Okay. Let me change color on that. Sorry. We're going to reflect it across this line right here. These two, A and B prime, are pretty simple because they're both 1 to the right, and now we'll just end up being 1 to the left. So A and B prime will be right along this one, with B prime being up here and C prime down below, or A prime. We'll get it. And then C, 1, 2, 3, 4. We'll go 1, 2, 3, 4 to the left. That's where C prime is. We'll do our segment tool to connect these. And now we're ready to do the next reflection across line M. That's this line right here. A is the easy one. It's just 1 above. So A double prime will be down here. B double prime, 1, 2, 3 above, 1, 2, 3 below. C double prime, 1, 2, 3, 1, 2, 3. And C is going to be down here. C double prime. And B double prime. Let's connect the dots for a new triangle, which looks like the last two triangles, except this one was rotated all the way about here. So what single transformation would have mapped this? Well, 180 degree rotation about the origin. And you notice that the lines are 90 degrees apart, and the result will be 180 degrees, or double the 90 degrees. Let's move on to the next one. Again, another one. You can do that on your own. I'm going to move to the next topic, and that's another type of composition. It's a special one called a glide reflection. A transformation that is a composition of a translation, a slide, C to C prime, and that's followed by a reflection, C double prime, being flipped across this line, is something called a glide reflection, as long as the line parallel, we reflect it across the line that's parallel to the direction that we slid this. Okay, these two have to be parallel to each other. The line that we're reflecting it about, and the line that's created when we slide those. Let's do a glide reflection here on this next one. So first of all, I've gone ahead and put the points on here. 2, -2 is A, 6, -1 is B, and 3, 0 is where C is. First thing they ask us to do is do this translation. You can see this translation is real simple. It's don't move on the x-axis, but just go straight up along the y-axis, up 4. So let's move A up 4. 1, 2, 3, 4. This is where A prime will be. C, 1, 2, 3, 4. And then B, 1, 2, 3, 4. Now we have our 3 sets of points here. I'm going to connect those so you can see what we have. And then that's going to be followed by a reflection. Now I'm going to go ahead and label these so we don't lose track of which one is which. That's something that you'll see on your test. If it asks you to label that, whether it's on a unit test or the end of course exam, you better label it to get full credit. It says label it A prime, B prime, C prime. Now the reflection is across this vertical line, the y-axis. You can see I'm going to start with point A. Point A is 2 to the right, and A double prime will be over here, 2 to the left on the same horizontal line. B is up here. Count them 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. B double prime is going to end up right over here. And we've got one more point to do. This should have been a double prime. Didn't show up. C is 1, 2, 3. 1, 2, 3. Along that same horizontal line. C double prime. Connect the dots. And there we have it. A glide reflection. Image 1, you'll see, went from 2, -2 up here to 2, 2. After that got reflected, A double prime ends up at -2, 2. Okay. I'll give you opportunity to fill in the remainder of these. They're just shown here. Okay. And I'm going to move on. You can pause if you want to finish that, to our next one. Okay, it asks us to do another glide reflection, and it starts off with the points -3, +5. 1, 2, 3, 4, 5 is where our A is. B is to the right 6 and up 2. And C, this is kind of a skinny looking one, is at 0, 3. So pretty weird shape for this one. C is right here. Connect that so we can see the triangle better. So a little skinny booger. All right, first one says let's go to the left 2. 1, 2 to the left is going to give us this triangle. It's kind of overlapping, might be a little bit hard to see, but it will look just like this. Each one of those points are just 2 to the left. So this is our A prime. This is our B prime. And changing colors makes this a lot easier to see. Now this time it doesn't ask us to reflect it across the x-axis or the y-axis. It says let's reflect it across the line y equals 1. Remember, y equals 1 is a horizontal line. It's where we go up 1 on the y-axis. No matter what our x value is, y is going to be 1. Choose any of those points. So that's what we're going to reflect this across. And you'll see that C is up here. Well, we'll start over here at B prime. B prime is one above this line. B double prime will be 1 below that line. That's the line of reflection. We're ignoring the x and y axis on this one. And then C, 2 above, 1, 2 below this red line. That's where C prime will be, or double prime, I should say. Now count this one. 1, 2, 3, 4. We'll go 1, 2, 3, 4. And this is our new A double prime. Connect the dots so you can see for sure that it is the same triangle. Just slid to the left and then flipped a top to bottom. And you can fill in those at your leisure. Okay. Next, this time we're going to be looking at some composites that aren't just any special type. They're just a matter of moving it once and then moving it twice in order to get to the new spot. Now, this one sure looks like a rotation to me. It looks like we've rotated all the way around here. But you'll notice when we rotate A 180 degrees, it's at negative 3, 3, and it's going to end up at 3, negative 3. Oops, that's not getting us all the way to here. So let's see what else we have to do. Let's go ahead and move B and C while we're at it. B is a negative 7, 5. So when we rotate this all the way around 180 degrees, the negative 7, 5 becomes 5, negative 7. So it's going to be, it's going to be over here at 7, negative 5. Almost got those flipped around. This is where our new B is. And then C is also 7 to the left, but it is up 8. So we'll follow that. We'll go to the left 7 and down all the way here to 8. And when I connect these, you'll see that we're pretty close to where we need to go. Okay, but we need to do another translation. We need to slide this down and to the right. Okay, so first of all, let's make sure we have the 180 degree rotation in here. And remember, what we do with 180 degrees is we just change the signs. So A started out at negative 3, positive 3, and then when we rotated 180, it ended up being positive 3, negative 3. So what happens is this becomes the opposite of x and the opposite of y. Okay, that's just a 180 degree rotation. It says write that rule with an arrow notation. Our next rule is the one we need to look at, and we already agreed that it would be easy to slide it. And in particular, we're going to have to go to the left 2. We all know that that's going to be an x plus 2. I said left. Crazy me. It should be to the right 2, which is going to be just x plus 2. But we then need to go down 1 to get to here. Notice B is the same thing. Left 2, down 1. Check out C. Left 2 and down 1 to get to there. So we've got our right 2. Now we need to go down 1, which is going to be a y minus, y minus 1. And we're done. We don't need to move it anymore. Let's go to our next one. Take a look at this one. In this case, a rotation really won't help me that much because you'll see I think we need to do a little bit of reflection in order to get this to this type of orientation that we see here. Okay, so first of all, if we reflect it, A is 2 to the right, A prime will be over here at 2 to the left. Okay, Let's check out B. 1, 2, 3, 4, 5, 6, 7. Start back here. 1, 2, 3, 4, 5, 6, 7 is where B prime will be. D is up here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And D prime ends up being here. Then C, 1, 2, 3, 4, 5, 6, 7. It's right above B, so we can put it right here. Then I'm going to go ahead and connect these dots so we can see what we have already. That's just a reflection across the y-axis. So you'll notice the y stays the same, but the x changes sign from a positive 2 to a negative 2. Positive 7, negative 7. Positive 8 or 9, negative 9, and so on. So our x's become opposites and the y is the same. Now, just like the last one, it looks like all we have to do is nudge it a little bit and we'll be back to where we need to be. In this case, it sure looks like we need to go to the right one and then go down 2. Let's check C. To the right one and down 2. They all should be the exact same. To the right one and down 2. To the right one and down 2. We end up at B. Okay, so what's that going to be? Right is x plus 1. Down is y minus 2. Okay, the next one. It asks you to decide how can we get from A, B, C, D to A prime, B prime, C prime. First thing it says is let's reflect it across the line y equals x. If you recall, we've seen this before. The line y equals x is this line right here. It's that parent graph. It goes through 0, 0, 1, 1, 2, 2. So if we reflect it this way, our image is going to flip like this or like this. So really all that's going to do is get B and D to exchange places up here, and there's no way that we can reflect it to get this new square down here. So no on the across the line y equals x. Let's take a look at the next one. This one says reflection across the line y equals negative 2x. Okay, so this is in y equals mx plus b. The plus b is 0, so we have a point right here at the origin, and then the slope is negative 2. Negative 2, down 2, to the right 1, down 2, to the right 1, down 2, to the right 1. Get our little segment tool here so we can connect the dots, and it's going to be this line right here that goes through those points that we just did. And this looks somewhat promising, but it quickly fades away when we look at this. B reflecting this way needs to go all the way down here. That's not going to occur. B prime would be somewhere up here. That's where B prime would be. So next one is also a no. Let's see if we can do this with a 180-degree rotation. The easiest way to do this is to get our patty paper. Now I can't do that with the computer as it's shown, but we can do our patty paper, sketch this, and then remember, rotate 90 degrees. That will get us right to here. That's where our y-axis goes to our x-axis. And this triangle is going to end up over here in this section. Okay, so we need to go another 90 degrees. B, which is right here, remember it just went right to here. Okay, B is right here. And let's go ahead and rotate another 90 degrees. 1, 2, 3, 4, 5, 6, all the way around. to 90 degrees. And yes, indeed, rotating of 180 degrees will result in this new square. Now, before we go to next, it does say all that applies. So let's check the remainder too and see if they work. The first one takes and reflects it across the x-axis. Our x-axis is this axis right here. So that's going to move the A to here, the D over here, C will be down below here, and then B is going to be right here. Okay, so that does not get us all the way over there, but it didn't say stop there. It says now reflected across the y-axis. And look what happens. We end up getting A right here, B right here, C down here, D up there, and lo and behold, this one also works too. Let's take a look at the 70-degree rotation. Okay, remember we're going in this direction when we rotate a positive amount of degrees. 90, 180, 270 is where this will be. Okay, so rotating, rotating, and then rotating. B will go to here, B will go to here, and then B will end up right over here. Okay, rotate, rotate, and rotate. Same thing with C. C is going to end up out here, down here, and then come right on up. I think I cut my B's and C's mixed up in here. This is where B will be. This will be where C is. And then A is down here. And then C is right here. So now I'm going to connect these to show you where that square is. And then the next thing it asks us to do is to reflect that, across the x-axis. That's not where we need to go. Reflecting across the x-axis is going to take this guy that's down here and send it in the wrong direction. We wanted it to go this way, but it didn't do it that way. So no on the last one. Okay. Let's take a look at our next page. And in this one, it says a figure is in the second quadrant. Remember, our quadrants are numbered 1, and then we go counterclockwise to 2, counterclockwise to 3, and finally we'll go down to 4 right here. Okay, and an object's right in here. It doesn't say us what it looks like, what it is. So when you see a problem like this, just make your own. Matter of fact, let's just put a point here at 2, 1, and another point here at 2, 5, and connect it and just say, hey, we got a segment between these two. And let's just do what it says. It says, first of all, let's reflect it across the x-axis. So you'll see if it's in quadrant 1 and we reflect it across the x-axis, it's going to end up only in quadrant number 4. This segment just got flipped down to here. Next, it says let's reflect that across the line y equals x. We've done this before. Again, y equals x is this line that goes through the origin in that direction. I missed it by a little bit, but you know what I'm talking about. Okay, it goes through 0, 0, 1, 1, 2, 2, and so on. So look at where that segment is. That segment is fully in quadrant 4. But when we reflect it across the line y equals x, this point here, which was at 2, negative 1, is going to end up at 1, 2. This one here that was at 2, negative 5, is going to be at negative 5, 2. that is it. This is after we reflect the second time. And then the third thing asks us to do 90 degrees counterclockwise about the origin. Okay, counterclockwise is going to go this direction. And where is that going to end up? It's going to end up being right down here. The final analysis says, or question asks us to look at what we did and what quadrant does the resulting figure lie in. It started in the first, went to the fourth, went to the second, and ends up in the third quadrant. Okay. I'm going to take a break, and then we'll finish the rest of the notes later.